Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rules in computing this given rational function. So we are given here with a rational function, and to find its derivative or to differentiate this, we are going to use the rule in differentiating quotient of functions because it is what is related to deriving or getting the derivative of a rational function. Again, we are given here with f of x equal to 2x plus 1 all over x. It's called a rational function because we have variables on both numerators and denominators. And then we're going to use here again the rule in differentiating quotient, which follows this manner. Since I have here f of x, let me use f of x. Okay, what if f of x is the quotient of k and m? I'm going to use other letters for functions so that it will not be confusing with regards to the already proven rule, where our m of x is of course not equal to 0. Obviously, this is differentiable if x is not equal to 0 here. So the rule is this. The first derivative follows this idea. You copy the denominator, you derive the numerator, minus, you copy the numerator, you derive the denominator, all over taking the square of whatever the denominator is. This is the rule in differentiating quotient of functions. Take note that the operation on our numerator is difference or subtraction. Hence, we cannot interchange the pairs of terms multiplied on our numerator. So we're going to solve for the first derivative of this given function. Hence, using this, you can use here a scratch paper. Your k of x is 2x plus 1, and your m of x, which is your denominator, x. The first derivative of k of x, using a derivative or rule in differentiating sum, you will have here to differentiate this using constant multiple, 2x1 minus 1, and then plus the derivative of constant, which is just 0. Hence, this is just 2, because x to the power of 1 minus 1 is 0, x to the power of 0 is just equal to 1. So 2 times 1 is 2. This is the first derivative of x. As for m of x, its first derivative is x, 1 minus 1, which gives us again 1, being x to the power of 0 is just equal to 1. So following this, simply substitute here all the details. We start with m of x. This is m of x. Look at this here. M of x is x times the derivative of your numerator, which is this, times 2, minus, we will copy the numerator, 2x plus 1, that's our k of x, times the derivative of your denominator, which is just equal to 1, all over your denominator, which is just m of x, and then you square this. This is by the use of this already proven rule in differentiating quotient of functions. Hence, by simplifying that, you have 2x minus, you have 2x, removing the grouping symbol, minus 1 all over x squared. Hence, your first derivative is equal to 2x minus x 0. You have negative 1 over x squared. This is the first derivative, or yes, the derivative of our already given rational function in this video. Please make sure that you follow the already proven rules, and we were able to prove that before we have these examples for better understanding. You can use this area here for your scratch for your guidance. Thank you very much for watching. So what are you waiting for? Subscribe now!